All right, we're recording now. So let me not be the first, hopefully, to tell you happy March. It's March 1st. Happy Mardi Gras. It's Fat Tuesday, which is what Mardi Gras means in the French language. It actually means Tuesday fat. Yeah, it's backwards, right? Like Spanish modifiers. It's also a Super Tuesday. So many of y'all have the opportunity to vote in today's primaries all over town. So that's awesome. Let your voice be heard. But again, that's figuratively. Don't go into the polling place shouting, right? Right. I want Baron Castile, right? Or Terry Isaac or whoever. Yeah, it's fun. It's fun. All right. Tonight is also the State of the Union address. Biden's first one. We didn't have one last year. Okay. All right. Example 22. Here are some tricky ones. Feel free to use that one tonight, Biden. Example 22. No, let me tell you something about Biden yesterday, because I want to share this with you. No, so anyway, I'm watching the news because my son is on Capitol Hill doing an internship, and when he's done working, he goes all over, and there's rallies everywhere, like in front of the Russian embassy and stuff. They were chanting "F-U worship, F-U worship," but it was from the Snake Island thing. You heard about that, right? Where the warship comes up on that remote little small tiny island in the Black Sea. I heard they're all alive. Yeah. But the Russian warship said, "We are a Russian warship, surrender." And there's all this talk. What should we tell them, boss? Yeah, tell them that. F you, Russian warship, and then they blow up the island, but everyone thought they were dead, but they're alive now, supposedly. But anyway, so they were in front of, right after that happened, there was in front of the Russian embassy just screaming that. And they weren't saying F you, they were saying factor you worship, factor you worship. So anyway, but anyway, so we're playing kind of this nuclear chicken right now, with Putin kind of like ramping up. But America is being prudent, right? We're being prudent. We haven't mobilized anything overtly. We're staying calm, right? And so he had a press conference yesterday, Biden did. And on the way out, there were reporters asking him with his mask on. He's walking out the door with his wife, and she said, "Mr. President, should the Americans be concerned or worried about a possible nuclear war?" And he walks by and he goes, "No." And he kept going. That's it. And so there you go. That is the self-assurance from our United States president. We don't have to worry about it, right? But it is a very delicate, thing. Okay. So I hope it doesn't come to that. But I will say this: I applaud the Ukrainians' resolve to fight for their homeland. It's pretty incredible. Yeah, they're having a good time with it, aren't they? Yeah. And then like some farmer hooked up to a tank and took off with it with his tractor. Did you see that? The tank is mine now. It's like, you go, Ukraine. Yeah. All right. Find this. Here we go. We got sine of x times cosine. Am I recording? Did I record all that? Oh, I did. Okay. All right. Post edit, Hank.
Shout out to all my Ukrainians on the corporate
Zach, we'll do that. We'll fix that in post edit, right? Yeah. Thank you. All right. All right. So sine of x times cosine of x. What do we do? We got a product of two variable functions. Is there a product rule for integration? No, there's not. So we have to say, okay, what do we take the derivative of to get that? Well, remember, when it's a product of two things, you want to maybe add layers, all right? Because you're going to have an outside function, and then the inside function might generate the other factors, right? Or only off by a constant multiple. So which one here could we call the inside function? Sure. Okay. So let's do that. If we're calling sine of x the inside function, then it is contained inside of blob to the first. And we check, right? What's the derivative of the inside function? Cosine of x. Perfect. Are we off by anything? No. So the cosine gets packaged back up. And now we're on to the rule of integration. Blob to the first becomes 1/2 blob squared plus c. And we don't walk away there, right? We come back and put the blob in there. And then if you want, you can simplify it like sine squared of x halves, if you want, plus c, something like that. Now, we've actually done this one. Do you remember? We did this one. And we also said, hey, you could do this one the other way around, possibly, right? You could actually let cosine be the inside function because it's also inside something to the first. And what's the derivative of cosine? negative sign. Now we're off by a what? A negative. So we have to have a -1 correction. And now the sign gets packaged up and blob to the first becomes 1/2 cosine of x squared plus c. Okay. And so remember, those would only differ by a constant. And we could use the Pythagorean identity to show that. So that one I threw in there just as a segue into the more complicated ones. But this is totally within the AP ballpark. Okay. So you might see something like that. Your hand is forced the other way. Remember, like if I had put this under a square root cosine of x, now your hand is forced, right? Now cosine of x has to be the inside function because the derivative of sine is certainly not the square root of cosine of x. Okay. All right. Look at this one here. Kind of the same idea. We have sine squared times cosine. If you write things that are in condensed form, in expanded form, again, it helps you see layers. So what could the outside function be when you walk up to it? What's up, blob squared, right? And what's the derivative then of its inside function? Cosine. So this would be the same thing if it had been the square root of sine, you would just write it as sine to the 1/2 power, right? Or if it were cosine of x over sine squared, you would write in the top as sine to the -2nd. So anytime you have a radical on one of them or an exponent on one of them other than 1, that's going to force your hand for that one to be the outside function. Now we're not off by anything, right? The derivative of sine is perfectly cosine. And now it's 1/3 blob cubed plus c. So this is another totally AP question. Just that should be like easy money, right? Like cha-ching, cha-ching, free points. Yes, yeah. And we can get them quickly because we're doing them by pattern recognition, not by Usubstitution. You want to see this one in Usubstitution? Do we have time? I don't think so. There's a 17-mile Russian convoy heading towards Kiev as we speak. We should. You know, he made the call for people to come help of any nation. And I was sitting on the couch with my wife last night. And I looked at her and I was like, "What do you think, honey? What do you think?" And she's like, no. And she said, "You if you did that, you would die before you even got there." And I was like, "Fair enough, honey. Fair enough. Thank you." She saved my life so many times, my wife. Yeah. Because I just have that urge. Like someone needs help. And I'm like, "Honey, I want to go help them," you know? And but like I wouldn't even be smart enough to buy a plane ticket. I would just like get in my car and start driving, you know, and then I get to the water. I'm like, "Oh crap, they're over there." And I just drive into the water. You know, I'm just that. Yeah, I'm just like a bull in a china cabinet, you know. And as the truck is sinking, I'm going, "Sisu," you know, whatever. Oh, thank you. Yeah. So here would be the Usubstitution. We would still write it like this. So we would have to do that step. Try to stay with me here on selective parts, please. I would have to say, let you don't have to write the word let, but you know, it's proper to do that, right? Like hear ye, let u equal sine of x. Now you're always going to want to take the derivative. So you can go right to du equals cosine of x dx, right? That's differential form. Or you could say du over dx equals cosine of x and then multiply both sides, either one. All right, now we could start with the changing of the variables. So instead of sine squared, it's now u squared. And what does cosine x dx become? Oh, it's a straight up du, right? And so now I've turned it into just a harmless little power rule, right? It's almost cute, isn't it? Look at it. So this becomes 1/3 u cubed plus c. And now we substitute back in. What is u? I love that question. It's sine of x, okay? So that's another way to do it with formal Usubstitution. Do you get the same answer? Yeah. It just takes a little bit longer. It's a few more steps. So again, if you're only off by a constant multiple, when you check the derivative of the inside function, you can do it by pattern recognition. Okay, it's not witchcraft if you do it that way, right? It's just a time saver. We mathematicians applaud when people recognize patterns. Okay, it's what we do. All right, now this one is it used to be kind of AP, now it's kind of on the fringe, but we need some help on this one, don't we? Because it's sine squared, and if you I did a figure 8. If you write it as sine of x quantity squared, you know, the layperson might just go 1/3 sine cubed plus C, right? Because they remember their plus C, right? Because their teacher teach them that. But it's like, dude, did you even bother checking the derivative of the inside function? Like, come on, man. Come on, man. No. Yeah, I know. He's doing the State of the Union tonight. So I'm watching. All right. So yeah, the derivative of sine is cosine. Is there a cosine out there? There's not. So what can we do? What are we going to do? Well, would the Pythagorean identity help here? Sine squared is equal to 1 minus cosine squared, right? Hey, that's better than doing nothing, right? You're like, come on, Putin, just come on in, right? No, we got to do something. We got to stand our ground a little bit. That'll work. Now look, what I've done, I've made the first term a 1. I can handle, there is a plus or minus rule, right? There's no product or quotient, but if I can make it into multiple terms, I can take the antiderivative term down the line, right? Just tank, 17 miles worth. Boom, 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 right? I know the antiderivative of 1 is x. Got it. But crap, what's the antiderivative of cosine squared? Well, we're kind of in the same boat. We're kind of on the same snake island as we were with sine squared, right? We can't just do something with cosine squared like we couldn't do it. So although it's not illegal and we can handle the first term, this also does not help, right? So we got to do something else. Are there any other? What else can we do? Are there any other? Well, Usub would. I mean, we could, but if it's not going to help, yeah. Is there any other identity that we can use? And the answer is yes. Well, yeah, I think we're past the knot and we're kind of hanging on to the frayed ends here. It's not an inverse trig, right? It can't be an inverse trig. It doesn't look anything like an inverse trig, but there is a power reducing identity. And I know y'all had it because y'all were in the super, most of y'all were in the super pre-cal last year. So the power reducing identity, these are kind of the last sets of identities that you need to know. All right, here it is. Sine squared of x is equal to 1/2 times 1 minus cosine of 2x. And cosine squared of x is equal to 1/2 times 1 plus cosine of 2x. So remember, cosine is me, cosine. Both of them are in terms of cosine. That's right. Right? He's kind of like the Putin, I guess, if you will, of the identities. The sine gets the minus sign because it's not in terms of itself, and the cosine gets the plus sign because it is in terms of itself. That's how I remember it. But it's a trade-off here. We half the power at the expense of doubling the angle, right? That's kind of what happens. We half the power at the expense of doubling the angle. And that might help us, okay? Let's see if it does. Sine squared is 1/2 times 1 minus cosine of 2 times x. Now, I wrote the 1/2 on the inside of the integral. I'm not going to take the time to write it on the outside. I'm just going to go ahead and put them already in my final answer. Now, again, I can handle the antiderivative of 1, just like with the Pythagorean identity. But notice it's a little bit different now. It's not cosine squared where I'm hamstrung. It's cosine of 2x. It's now a composition, right? And my outer function is cosine of blob. So I've changed the inside function. The inside function is now 2x. Whenever you have a linear inside function of the form mx plus b, it's going to work. Because what's the derivative of a linear function? A constant. Yeah. And we can be off by a constant. What's the derivative of 2x? 2. Do we have a 2 out in front of the cosine? No, but we can correct it by having a what there? A 1/2. Okay, so that's just me considering it. Now I'm going to go for it. 1/2 beefy bracket. What's the antiderivative of 1? X. Okay, got that. And then minus, now I do this little trick here. I have a 1/2 correction just in front of the cosine. And I notice I already have the minus sign there. So I'm just looking at cosine. What's the antiderivative of cosine? Is it sine or negative sign? It's regular sign. Yeah. And again, because we could do the check, right? What's the derivative of sine? Cosine. And notice I'm not even considering the negative. I'm in that part because the negative is part of my constant multiple. See that? Okay. And now if you're not sure, take the derivative and see if you get the line above. And of course, we'll garnish it with the plus C on the side, right? Okay, so that's it. The power reducing identities make it possible, right? Go gadget math. So we'll cover this again briefly when we look at polar area at the end of the year. When we set up an area problem with polar coordinates, it's usually involving trig, of course, because it's polar, as you'll learn, and then it's area, so it's usually squared. So if we don't have a calculator, this becomes kind of a very routine thing that we do. Okay, so yeah, I'll say this is right there on this is AP. Yes, we'll say this is AP. Yes. All right, now this one might be out one step outside AP. Okay, all right, so here's AP, and then we're like right here. We're one step out of AP. Right here's AP, and then pretend there's a door there, and we're just stepped down the outside like for a smoke break, but we don't really smoke. We're there for a fresh air break. Fresh air break. There you go. Don't smoke. It's bad. All right. Sine cubed. Sine cubed. Well, guess what? If we do the same little thing here, sine of x, you know, we do 1/4 sine to the 4th, right? No. I applaud your enthusiasm, right, honey? But you're gonna die before you get there. You can't drive your truck right across the ocean. Right? Okay, honey. What you say? Thank you. Right. Stupid husband brain. Just listen to women, guys. Right? I listen to Miss Lincoln when I'm up here. I listen to my wife when I get home. It's the key to success.
You can go on vacation to Bahamas. Okay.
Yeah, I'll meet you there.
He said it's not Bahamas. It's actually great. Funny frame. Come go to war with me.
Oh yes, that works too. That works too. All right. The derivative of sine is cosine. There's no cosine outside there, is there? So we're kind of in the same boat. But notice here, the power reducing identity is not going to work as we know it, because we could half the power and double the angle, but halving a 3 would turn it into a 3/2. Say it with me, yucky, gross, right? We don't want to do that. So this one, I call these odd man out. I'm gonna sit over here for a while. I like it over here. Yeah, closer to the exit. Yeah, odd man out. Odd man out. Not that we want to exclude anybody, but we have an odd power, right? It's an odd number. So here's what we're going to do for something like this. We're going to first call this sine squared of x times sine of x. Everyone okay with that? I hope so. Now, so what we did is we took the odd power and we took one of them out. That's why I call it odd man out. Now what we're going to do is something we've actually tried before. We're going to turn sine squared into cosine a la Papa Pid. So sine squared becomes 1 minus cosine squared. And you got to be careful because it's in parentheses. Now, I guess we don't need this this outer one because it's a product, right? Now, how does that help? Well, not in this format, it doesn't help, does it? But here's another strategy. There's some obvious math we could do. Yeah. Let's distribute. And we get sine of x minus cosine of x squared times sine of x dx. And now we have two terms. And remember, if you have multiple terms, you can treat each term as its own separate integral. I didn't do that. I just keep them all in parentheses with one bookend on the right-hand side. Now, before we do anything, we want to make sure we can do everything. So don't integrate one term at a time if you can't integrate all of them, because the notational burden is way too high, okay? So just consider them as you go down the line. Do we know what the antiderivative of sine is? Yeah, it's what kind of cosine? It's negative cosine. And over here we have a product. And if you notice the way I wrote that, the outside function could be blob squared. What would the inside function be? Cosine. And what's the derivative of cosine? Negative sine. We're only off by a negative, right? Unless you want to count the negative in front. Do we have a way then to anti-differentiate or integrate both terms? Yes. And now we'll integrate the whole thing. So now we get rid of the integral symbol. Now we get rid of the parentheses. Now we get rid of the dx. The antiderivative of sine is negative cosine. And if you're unsure again if it's positive or negative, because that's a big mistake, take the derivative of that. What's the derivative of negative cosine? positive sign, right? All right, and then the next one, I like to just say, hey, this negative here, it just goes along for a ride. And now the derivative cosine is negative sign. So I have to have a correction of a -1. So this right here, in my case, is my rider. And then I have a correction of -1. And now I'll go to my rule coefficient, 1/3 blob cubed plus c. So here is your rule coefficient. And what's going to happen when I simplify is a negative times a negative is going to turn into a positive, yes? So then it just turns into plus, and you can write it as cosine cubed of x over 3 plus c. So that works anytime you have an odd power. Okay, you can keep one of them out and then use Pythagorean identities to chip away at it. That's a lot of work, right? But that's kind of cool insight that you know, you find a way. You're going to be given primarily, you know, integrals that are going to have a way out. There is an exit to the maze. It's not going to be like, we're going to give you an integral that doesn't have no closed end solution, as we say, and just let you sit there and struggle with it. That would be like giving you a trig proof and say, here, prove it. And we know that they're not really the same. And you're sitting there at home going, I can't get it. And we're like, we should mail a bunch of those to Putin to keep him frustrated, right? Yeah, solve this, Putin. Prove this identity. Snicker, snicker. It's not even an identity. All right. So any comments or questions on those? Triggy ones. Triggy. Okay. So here's a lob pitch serving as a confidence booster. Like we need that, right? We're pretty good. Hey, guess what the first thing I'm going to do is? I'm going to realize that there's only one function there. There's not a product of two variable functions. But I do see a radical. And I know that if I write it to the 1/2 power, it puts it in a form that I can maybe anti-differentiate. Now, bless you. The inside function here is linear. And that's why we don't see another function, a variable function outside. Because the derivative of a linear function is just what? A number. So what's the derivative of 2x minus 1? 2. Do we see a 2 out front? Nope, but that's not a problem because we can correct it by putting the reciprocal of the unwanted number, right? And now we go to the power rule, and it's going to be, leave a space. Blob to the 1/2 plus 1 is 3/2 times the 2/3 in the front plus c. And of course, we don't leave it like that, right? We crawl into the tank, put 2x minus 1 inside there. And then you can simplify, right? The 2's divide out, and you're left with 1/3. You could say it's the square root of 2x minus 1 cubed plus c. That would be kind of the simplified version. Confidence booster, right? All right. It would be the same thing if we had something like the integral of g prime of 1/2 x dx. Confidence booster. What's the outside function? G prime of x. Do we know what the antiderivative of g prime is? It's g. Now, it has an inside function of 1/2 x. What's the derivative of 1/2 x? 1/2. Do we have a 1/2 out front? No. If we're off by a 1/2, all we have to do is have a correction of 2. And now we move on to the rule of integration. The antiderivative of g prime of blob is g of blob. Okay. And then you would evaluate it from whatever to whatever. So it would, whenever you plug in, that was one on the 5 questions yesterday, right? Something like that. So when your inside function is linear, you're probably not going to see a product of two variable functions. Okay. Pattern recognition will still work. But compare that to number 24. It kind of looks the same, don't it? But there's this fella knocking on the door, right? Hey, can I hang out here? You're like, no, go back to your country. Right. Well, let's see. Oh, I put X. I'm getting kind of crazy with the X's. There we go, dx. Can we do the power rule here? Some people might just jump in and use the power rule here. right? The outside function is blob to the 1/2. We know better than that. We got to check. What's the derivative of 2x minus 1? 2. Are we only off by a 2? No, we don't even generate that x. We're like, where in tarnation did that x come from? It certainly didn't come from someone unpacking the box blob to the 1/2. Man, yeah, I wish you would go back to your country, right? That's kind of the universal sentiment in Ukraine right now. So what do we do? What do we do? Well, this is a new strategy. Okay, so here it is. This is where you have to use Usubstitution. So what are the conditions? Well, first of all, it's going to be limited when your inside function, and I put that in quotations, right? Which is what we're calling U, is linear, which is mx plus b, right? Or smaller. I'm throwing that in there because it does work. What does that really mean? That means if your degree of your inside function is x to the first or smaller, like x to the 1/2 will work. You probably won't see the smaller though. It's primarily on the AP exam limited to linear. Okay, that's the first condition. And when you were off, quote unquote, off by more than a constant. That's what's happening here, right? We have an inside function that's 2x minus 1. That's a linear function because it's x to the first. When I took its derivative, I only got a 2. I didn't generate the x. So I was off by more than just a constant. If those two conditions happen, then you must use Usub. Okay. And it's going to become a little more clear to you why it has to be linear or smaller when we actually do this problem. Okay. All right. So let's go ahead and try that. I'm still going to write it like the line below. I'm still going to write it to the 1/2 power. But my inside function is still 2x minus 1, right? What is the criteria? That's what I'm looking for. Thanks, Zachary. The criteria, Zachariah. Do I call you Zachary? Is that okay?
I actually don't mind. I think it's kind of endearing sometimes.
Oh, okay, okay, yeah. He lets me call him Zachary, right, Elena? Yeah. Okay. Sorry. Okay. The criteria for calling the inside function 2x minus 1 is the same. It's inside the more interesting outer function because what is the alternative? X is inside something to the first, right? Boring. So we're still going to say let U equal 2x minus 1. We know we're going to need du. So let's go ahead and take du is equal to 2 dx. Are you okay with that? Or du dx equals 2, and then multiply both sides. Now remember, what our goal is when we do Usubstitution is to take everything that is xy about this one and turn it into something that is ue, right? I got 3 pieces. I have this piece, and this piece. If I'm only off by a constant, I can usually replace the x dx piece with a single constant and a du, but I can't do that here. So let's just go ahead and replace things from left to right. I don't know what x is, but I do know that 2x minus 1, I can now write it as u to the 1/2 power. Yes, yes? So I got that piece out of the way. And dx, do I know what dx is? Yes. I can solve for dx, right? Very good. Dx is equal to du over 2, also known as 1/2 du. So I'm going to put that over here, 1/2 du. So of the 3 checks that I have to make, I've got this one taken care of, and I've got the dx taken care of. And because I was off by more than just an x, I can't just package that x back up with the du. But I can solve that for x, can't I? And the reason I can solve it for x with a single solution is because it is linear. If that were quadratic, there might be 2 solutions. If they're cubic, it might be 3 solutions. So that's what we need to do. And this is why it needs to be linear. We want to solve for x. So carefully we do that. We get 2x equals u plus 1. And we get x equals u plus 1 divided by 2. Well, I can write that as 1/2 times the quantity u plus 1. Wow. Because it was linear, it was easy to solve for x, right? Algebra 1, we call that. So let me plug that in here. That's 1/2 times u plus 1. Oh boy, now I did it. I did it. I did it. Yeah. What did I succeed at doing? I just changed the variables. Now notice, because it's an indefinite integral, there's no intervals of integration to change as well, right? All right. So all I got to do now is clean it up carefully. If I clean it up, I'm going to have a 1/2 times a 1/2. Hi, Coach Fair. Let's bring the product of those out front. That is going to be a 1/4, bless you, times the integral of. Everyone okay with that? And then I'm going to have a u to the 1/2 times a u plus 1 du. There's the cleaned up version. Now, why is that any better than what I started with? I still have the product of two variable functions. Now, if you look at what your outside functions are, it could be blob to the first. What's the derivative of u plus 1? 1. Is that equal to u to the 1/2? No, crap. Oh my goodness. Oh my goodness. I don't even have to consider this being the outside function, blob to the 1/2, where the derivative of u is 1, not u plus 1. That doesn't work. We are able to do something here, as Hank just noticed, that we could not do before. And what was that, Hank? We can distribute the u to the 1/2. Now, this is why Usubstitution in this case is powerful. We turned the two-term binomial to the 1/2 power, which we're hamstrung. We don't know how to expand something to the 1/2 power, right? If that had been 2x minus 1 squared, easy, right? Square multiply double square, distribute the x, boom, boom, boom down the line. But when it's to the 1/2 power, we're like stuck. But by turning that binomial into a single something, and now the other single something into double, now we can expand it out. So when you have to use Usubstitution, that's always going to be the next step. Once you clean it up, you're always going to expand it. All right. Now at this point, if this u plus 1 were squared, which you might see sometimes, that's not a problem either. Because if u plus 1 is squared, you could expand that out first and then distribute the u to the 1/2. Okay. So what does that look like? Well, we get 1/4 times the integral of parentheses u to the 3/2 plus u to the 1/2 du. And now I have two terms, and they're both in the ax to the n format. So now I can integrate them. 1/4 beefy bracket. I think this is time for the beefy brown bracket, right? And I'm going to send this all the way to Ukraine. The beefiest of the brownest brackets. Take that, Russia. That's my contribution, right? Beefy brown brackets of, let me see. Oh, I thought it might snap to it. You know, you could snap to, you could snap to a triangle, right? You should be able to snap to a beefy brown bracket. Maybe I'm going to, yeah, but I don't want it to curve. I want it to be beefy, straight, no, straight, right? Okay, there we go. Anyway, beefy brown bracket, got it? What is the antiderivative of u to the 3/2? Yeah, good. U to the 5/2 with the 2/5 in front, very good. Plus u to the 1/2 becomes u to the 3/2 with the 2/3 in front, plus c on the outside. And guess what the last step is? Yeah, plug u back into what u is. If you want to distribute the 1/4, have at it. But the last step is to substitute u back in. And so here comes my favorite question. What is u? There you go, 2x minus 1. 2x minus 1. Okay. And at this point, if we really wanted to get it back to a product of two things, we could factor out least powers, couldn't we? Ooh, remember doing that? We could factor out a 2x minus 1 to the which one's smaller, 3 halves or 5 halves? 3 halves. We could do that. But that would be if we were trying to use it, like if we were trying to find critical values. I doubt that that would be an answer choice. So this used to be like if you saw one question on the AP exam where it just said to find the antiderivative and it didn't give you a hint, you would be lucky, right? Some years you would go without seeing a question like this. Nowadays, as you know, they make the test a little bit more user-friendly, right? Instead of 5 choices, there's 4. There's no penalty. There's no deduction of a quarter point for a wrong answer, right? It's +0 if you get it wrong, and it's +0 if you leave it blank. They used to deduct points. So what they do now is something a little bit differently, all right? I'm going to kind of skip all these. If you want to see these, you can. These are just other variations of it. Okay, I'm going to skip those. This is kind of what we see now. Not that you won't see what we just did, but example 25. Use Usubstitution to answer the following questions. All right, so this might be like a free response scenario where they're telling you to use Usubstitution, or they might even give you the Usubstitution. If U is equal to this and is substituted in, what is the new integral? Okay, so let's go ahead and read this. If the integral with respect to our dx over 1 plus cosine of x is tangent of x halves plus c. Okay, good to know. I don't think we need to memorize that. But here's what I don't like. I don't like the dx in the top. Do you? So I'm just going to rewrite that as 1 over 1 plus cosine of x dx. And I know that that's equal to tangent of, I'll call that 1/2 x plus c. I'm just putting it in a format that I prefer. Okay. Now here's what's cool. Remember, this x doesn't have to be x, does it? As long as they all match, it's good, right? It could be 1 over cosine of p with respect to p equals tangent of 1/2 p, right? Little p, right? Lowercase p, like little Putin, right? As long as they match, it's all the same. Yes, yes? Yes, yes. Okay. So it says now to find the integral of 1 over 3 plus 3 cosine of x fourths. Exactly, where c is some constant. Okay, all right. Well, if you're looking at this right here, you're like, okay, I have to use this to help me find this, which means I have to try to make this integrand look like this integrand, or more like this one here after I rewrote it. I got to make those look the same. Okay, I got to make those look. How can I make those look the same? It says to use Usubstitution. So what I have to do first and foremost, I guess, is realize that this has to be a single variable, right? It's cosine of x. And right now I don't have cosine of x, I have cosine of le blob, right? So if I'm supposed to use Usubstitution, you think this is kind of where we're supposed to use it? Yeah, so maybe I'll say let U equal x over 4. Okay, which is the same as 1/4 x. So the derivative of u must equal 1/4 dx. Okay, so what is that? Well, I need to replace this and this. Well, I already got, let's go ahead and do that. 3 plus 3 cosine of u, but I need to solve for dx, don't I? So to solve for dx, I'll just multiply both sides by 4 and I get 4 du. So I'll put the 4 du right here. Okay. You know what that did? That made it look a little bit closer to the first one, but there's still some stuff hanging around, aren't there? This is supposed to be 1 plus 1 cosine of a variable. I have 3 plus 3 cosine of a variable. What could I do here to get rid of both of those 3's? Factor out a 3 from the bottom, which is good. Factoring out a 1/3 from the whole thing. So if I factor out a 1/3 and I bring the 4 factor that's out behind it out to the front, that's really a 4/3 out front now, isn't it? And that's 1 over 1 plus cosine of u du. Looking good, right? Now, because I have this piece here, whoa, I have this piece here looking like this over here. I can integrate it using the key essentially that they gave me. The hard work is over. In other words, I've manipulated it into something that I recognize. So now the 4/3 goes along for the ride, and I guess it's equal to tangent of 1/2 of u plus c. I'm still in u, right? I have to integrate it with u. Okay, that's what they told me. 4/3. And now what? What's the last step when we do u substitution? Yeah, bring u back, whatever u was originally. That is if it's an indefinite integral, and it is. So what is u? U is x/4. So it's 1/2 times u, which is x/4, close plus c. And now if you simplify that, you get 4/3 tangent of, you get 1/8 or x/8 plus c. Okay. There you go. So it had a little bit of, it didn't tell us exactly which to use u for what variable. We could figure it out. We always let the composition, the inside function of the composed function be u. We didn't want to let the whole denominator be u, because then we're going to get 1 over u, right? And we're trying to make it 1 over 1 plus cosine of a single variable, right? Now, I don't know, this is 2022. Maybe now, instead of just saying use u substitution, they'll say let u equal x/2 and then find it exact. So they're giving more to you. I don't, yeah, is that a good thing or a bad thing? I don't know, mixed feelings about that, right? You don't get a formula chart, so there's so much that you have to know going in that we learn, that you kind of require by repetition, by practice. You got to know a lot, right? Okay. Any comments on that one or any questions? Got my bench work off to the side. See, here's my bench work. And then I have the flow of my project working straight down there uninterruptedly. All right. Let's look at part B. Part B is interesting because it's the integral from 0 to where? Infinity. You're like, whoa, that's way down the line, isn't it? We call this an improper integral, and we're going to study those one day later on. For one day, not just one day later on, but for one day. Improper integral. Okay. And believe it or not, it has a finite value. It's an unbounded region. If you're integrating that curve from 0, you're going out forever and ever 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 and ever, and it's equaling pi squared over 12. Let's look at this. What would be the limit as x goes to infinity of x over e to the x plus 1? In other words, as I don't know what the curve looks like, but if I did let x go out to infinity on my integrand, what are the y values approaching? Which one's growing faster, the top or the bottom? The top is linear and the bottom is exponential. So the bottom is growing a lot faster, isn't it? And anytime you have a ratio and the bottom grows faster than the top, it goes to 0. Yeah, so the integrand has a horizontal asymptote on the x-axis at y equals 0. So the fact that, and I don't know what the graph's going to look like. You can figure out what the y-intercept is at 0. It's probably going to look something like this, I'm guessing. And there's a horizontal asymptote. And so what we're doing is we're integrating from 0 all the way forever and ever and ever and ever and ever, right? Is that horizontal asymptote ever going to touch the x-axis? No. So will the boundary of the region ever close off? No. We're going to be acquiring more and more and more and more area forever and ever and ever, kind of like Putin's plan, right? But unlike Putin's plan, this one actually has a stop to it. And this is where kind of the contradiction comes in. Even though it's an unbounded region, you could zoom in anywhere you want down the line forever and ever and ever, and you'll find space. You'll find more area that we're acquiring. We're just acquiring it at a rate that's, less and less and less. It actually converges, we say, to a finite value. Okay. So on the one hand, you're like, how can it be a finite value if it's an unbounded region? We're finding the area and it goes on forever. Shouldn't the area be infinite? Well, in some cases, yes, but in this case, no. It all depends on how fast the function goes to the x-axis. If the function converges towards the x-axis fast enough, it will converge. If it converges to the x-axis slowly, then probably not, okay? So anyway, that's just kind of a segue into improper integrals later on. I could show you kind of another, I think I showed you before, where you keep adding half of what's left of a penny forever and ever and ever, and then you eventually get 2 cents, right? So do we do that? Yeah, so here's 1 penny, and now on the next day, I'm gonna add a half of a penny. And on the next day, I'm gonna add half of that, which is a 1/4. And on the next day, I'm gonna add half of what's left, that's an 1/8. And on the next day, I'm gonna add to it a half of that, that's a 16th, right? And I could keep dividing what's left over. In theory, I could do it for how long? Forever and ever and ever. There's always gonna be a little sliver. But as I keep adding this up, the total is just gonna get closer and closer to what? 2 cents, right? So this one actually goes to 0 fast enough. 1/2, 1/4, 1/16. This is the graph. This would be the integral from 1 to infinity, if you will, of like 1 over x. Well, what would it be? 1 to, we're doubling it, so 2 to the x. Yeah, 1 over 2 to the x, or 1/2 to the x. Okay, exponentials typically go to the x-axis fast enough to converge. So anyway, all that aside, we know it equals pi squared 12ths. I want to find the value of this exactly. Well, what's the only difference? The only difference is this, right? That's a 5x. So you might want to say to yourself, hey, look, bless you, the inside function is 5x. Take the derivative, we're only off by a 5. Right? There's no 5 up there, so we can have a correction of a 5th. So could it be that that answer is just a 5th of pi squared 12ths? Well, let's see. We better do it formally. Let's let u equal 5x so that du equals 5 dx. And now if I solve for dx, I get 1/5 du. Let's go ahead and change the variables now. It's going to be the integral from, well, let's see. Instead of e to the 5x, it's e to the u. And the dx is going to be a 1/5 du. But look at this. What is x going to be? Have I solved for x yet? No, I have to solve for x. So if u equals 5x, x equals 1/5 u. Oh, I gotta have a 1/5 u up there as well. And in the bottom, I get e to the u plus 1. Now, here's the cool thing. If I want to put it back in terms of x at the end, I would leave the intervals of integration off. But because it is a definite integral, remember, if I want to change those intervals, which are x values, into u values, I don't have to put it back in terms of x. Okay, what do you want to do? Let's change them. Let's change them. When x is 0, what is u? 0, yeah, you plug it into here. It's 5 times 0, which is 0. And when x is infinity, what is u? Infinity. Ah, so it ends up not changing the intervals of integration. Nice to know. So notice in this case, I wasn't just off by a 5, I was off by a 25, really. So if I pull the 1/5 from the front out there and the 1/5 on the back and combine them, I get 1/25. The integral from 0 to infinity of u over e to the u plus 1 du. And now does that match this form right here? It does. And because I changed the intervals of integration, I don't have to substitute u back in. I can just say, okay, this thing right here is equal to, what was it, pi squared 12ths. So the one that I was looking for is going to be 1/25 of that. Hey, Mason. Hey, no worries. Okay. Let's see. Y'all want to try this one on your own? There's like 4 minutes left. And try it. Try it on your own. I think I'm going to skip this down here because we've already talked about it. Right? If you integrate an odd function with origin symmetry on a symmetrical interval from negative a to a, it's going to equal 0, right? But if you integrate an even function on a symmetrical interval, it doesn't equal 0. But what you could do is you could double it from 0 to whatever. Okay, we'll call this negative a. And so that could be nice, as we've already seen, because if you get 0 as a interval of integration, it's nice. So we've already talked about that. So I'll leave that alone. But go ahead and try this. I'm going to work this quietly since there's only 3 minutes left, and then y'all can compare your answer to mine. Yes. Oh, yeah. Oh, yeah. One of those is on spring break, the March 15th one. So you just want to like push the schedule back from there? Okay. We'll edit that. Thank you for letting us know. Yeah. I mean, if we're all here on spring break, we don't have to miss each other for so long, right? Thank you. Yeah, we'll fix that. When's the next one, Landon? This Thursday. When and where?
8 a.m. in this working room and then 7th period.
Oh, okay. You can do it twice? 7th period and 8 a.m. in this room. Thursday. There you go. Yeah.
So when it's 0 to 10,
Mm-hmm.
I'm confused with the 1/2, the correction.
Oh, that we don't have to question that. That's just given to us. It's saying if we see this, just call it this. And that has the X over has built into it. Yeah. Yeah. So and I like to, instead of calling it X over, I just like to call it 1/2 X. So we can just trust that. So when I did the substitution down here, I have this piece here, right? And I can say, okay, the 4/3 goes along for the ride. And now it's going to be whatever this variable is, it's tangent of 1/2 of that variable, right? Tangent of 1/2 of that variable. So that's why I just put tangent of 1/2 u. And then I substitute u back in and just combine. Okay. Yeah, you bet. You won. You were Ukraine and the lid was Russia, Ben Dooley.
That's what I'm saying, yeah.
Yeah. I mean, it was a fight. And it was, I heard a lot of wrestling going on, but you prevailed.
I opened it back up to put a plastic bag that was in the paper recycle.
Oh, you're fantastic. But you know that. Thank you.
Thank you. Appreciate it.
Remember, if you do use substitution on a definite integral, change everything, including the intervals of integration. If it's an indefinite integral, then you plug back in at the end. Okay. So that one, if you see the work on the side, I try to show all my work and then I plugged in. And again, I'm trying to do the integral in the flow of the problem straight down. And the first line I wrote is where I'm doing my change. So I substitute it kind of in the same space. And then on the next step, I consolidated. But 0 to pi/5 changed to 0 to pi when I plug those values in to u equals 5x. Okay. And once it matched, then I can just replace it like an identity with what it's equal to times my correction. So there you go. All right. We finished 4.4 for what it's worth. Okay. That's kind of where I'm going to stop. I think I'm ready to get out of 4.4. For here on, it's just practice, 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 practice. And then for good measure, I'll just throw another one in there, practice, and then repeat. Right. Okay. Yeah, you can turn the notes in. And then if you're doing the optional worksheet, just turn those in by the end of the 9 weeks.